Good morning, good afternoon, or good evening, everyone out there. Welcome to the newest edition of our TechXchange webinar. We truly appreciate you taking the time to join us for this 30-minute session today. My name is Daniela, and I will guide you through this presentation. Before we begin, here are a few details. This webinar is live and is being recorded. All microphones are muted, so if you have questions, please use the Q&A section on the right side of your screen. We will address the questions at the end of the session. If we run out of time, we will follow up with you afterwards, or we also will answer the questions later and share it with all the participants. In our TechXchange webinars, we provide you with in-depth knowledge and updates on reciprocating compressor technology. Today, we are looking into repairs and reverse engineering of crankshafts. And these are our three key takeaways of today. How we contribute towards the sustainability through our repair capabilities. And you will learn from a real-life case where we used the laser cladding technology to repair a 5-meter crankshaft. How an engineered solution was developed for a non-Burckhardt compression crankshaft where repair was not feasible. So we are delighted to have two experts joining us today. It is Matthias Reese. He has been working in the compressor industry for almost 20 years. And he has been with the company since October 2016. Since last year, he is leading the team Project Solutions in Bremen, Germany. In the background, he has our dear colleague Jan de Koning, who is responsible for the crankshaft repairs at our service center in the Netherlands. And we also warmly welcome Madhurya Müller. She has been with the company for over 10 years as sales manager, upgrade and revamp projects. Now, before handing over to my two colleagues, let me quickly make a short introduction to our repair capabilities. We have over 34 service centers worldwide, but all of them are very much connected to each other. So they share know-how and all of them follow consistent repair guidelines and standards. They are also verified yearly by internal and external audits. We also value high the local needs by providing reports and documentation in the local languages. As a result, repair quality is high and reflected in our warranties that we offer. Further, we hand over a detailed report to our customers after the repairs. So with our pragmatic maintenance mentality, together with the fast access we have to the OEM engineering knowledge and our technical support, we offer the repairs for all brands of reciprocating compressors. So be it from valve service to complex packing, high-pressure packing repairs and entire compressor overhauls. Here on the bottom, I share an example from a chlorine plant. On the left picture, you see the dismantled parts arriving at our service center. Then in the middle, after repair and assembly, they are ready for the test. And finally, back in operation on site. The customer received a like-new warranty for that overhaul. A last point to highlight here, that our service center in the Netherlands is an approved vendor for component repair work for marine applications. So you will hear more about this later, Matthias. Now speaking about sustainability, how do we contribute towards sustainability? It starts already with the design. So our plate valves, for example, are designed with an increased thickness that allows the remachining in our service centers for up to 20 times. The plungers used in our hypercompressors handling pressures of up to 3,000 bar are made of the costly material tungsten carbide. So the most sustainable and economical approach here is to reuse the plungers, of course. In our service centers, we recondition the affected running surface, and depending on the severity of the damage, they can also be refurbished up to 20 times. To give you here also some dimensions, over our service centers worldwide repair over 30,000 components in a year in an average. In addition, through revamps, modernizations, and refurbishments, we give entire compressor systems a new ease of life. So in addition, we have the possibility to reuse old compressors and adjust them in our service centers to the new process parameters. The demand of the so-called second-hand compressors is increasing. So reusing an existing compressor means we can reuse the raw materials. No transport from sub-suppliers, no production of new parts, nor main components are needed. But how can we measure sustainability? We made here the calculation, look at the saved cast material. On an average, about 1,000 kilowatt hour of electricity and 100 kilo of coking coal are required to produce 1 ton of cast iron. The use of which is associated with corresponding emissions of between 1,500 and 2,000 kilo CO2 per ton of good cast iron. So looking at our average second-hand compressor we yearly deliver, we save around 6 tons of cast iron a year, which equals an approximate saving of over 100 tons of CO2 emissions over the past 10 years. So on the picture here, you can see one of these second-hand compressor before and after the overhaul or repair. It was used for a propane application. So with regards to sustainability, I'd like to make a last point here and highlight that our service center in the Netherlands repaired over the past 20 years over 9,000 crankshafts. So one of these crankshaft repair will be now presented by Matthias Rehse. The floor is yours.
Thank you, Daniela. I will share my screen and start with the laser threading of crankshaft. Yeah, good morning, good afternoon, or good evening also from my side. Me and Jan de Koning in the background would like to talk about repairing compressor crankshafts using laser cladding. As you probably know, compressor crankshafts are highly stressed components that can suffer wear and damage over time. Laser welding is a precise and efficient method to repair such damages as it enables precise work with minimal material deformation. In the following slides, I will explain the advantages and possible uses of this technology in more detail from a real-life case where we used the laser cladding technology to repair a 5-meter crankshaft. Yeah, the case we are presenting here is a crankshaft that comes from a compressor on an LNG tanker. The compressor itself is a so-called Labi GI with a speed of 455 RPM and 1035 kilowatt drive power. What is important to mention here is that we have the witnessing certifications amongst other classification society like Lloyd's Register of Shipping, Bureau Veritas, DNV, RINA, NKK, ABS, Russian Register, and more renewed inspections agencies and classification societies. As you can see on the photo, we received at our facility BCNL in Schiedam, it is near Rotterdam, the crankshaft heavily corroded caused by hazardous environment and poor storage. The crankshaft has a length of 4,950 millimeters and a weight of 2.4 tons. At this crankshaft have 7 main bearing pins and 6 crank pins with a diameter of 240 and a length of each pin of approx 185 millimeters plus the conus. That means we have a weld area of more than 1.8 square meters. Yeah, our first step after unpacking the crankshaft was our so-called step 1, the incoming inspection. We always perform an initial inspection on crankshaft upon arrival. This is the first step in our process to assess their condition and determine the necessary repairs. The incoming inspection consists of the following steps. the visual inspection, the concentricity and diameter inspection, the roughness measurement, the hardness test, the die penetration test, and all affected dimensions before repair should be measured. On the photo, you can see also the blue frill check on the conus of the crankshaft together with the flywheel. You can see the conus, the flywheel is not shown. This is the point that is also very important. We always recommend it to our customers, also sending the flywheel as well. The die penetration test was shown on the 3 pictures here below. Now we will explain something about the laser welding process. Why do we use laser cladding as repair method and not the metal spraying? The advantage of the laser welding over flame spraying or HVOF spraying is mainly the higher precision and the smaller heat affected zone. 5 specific advantages are the smaller heat affected zone. With the laser cladding, the heat is introduced in a very targeted manner, which leads the minimal deformation of the workpiece. This reduces the risk of stress or cracks in the material, which is particularly important for thermally sensitive components such as crankshaft. Another one is high precision. Laser enables very precise and targeted processing. This allows specific areas of the crankshaft to be repaired without affecting the surrounding material. Strong material adhesion. With laser welding, the material fuses directly to the surface, resulting in a very strong bond. This can offer greater strength compared to applied layer, such as those created with flame spraying or HVOF spraying. Less post-processing. Due to the precise application of the material, less post-processing such as grinding or turning is often required. This saves time and cost in the repair process. The last one is the less porosity. Laser welds tend to have less porosity compared to sprayed coatings, which increased durability and resistant to fatigue. Overall, laser welding is particularly suitable when it comes to high precision repairs and minimizing thermal stress, while flame spraying and HVOF spraying are more suitable for larger area coatings. How do we at Burckhardt carry out a crankshaft repair? At first, all surfaces are preheated before starting cladding. As opposed to many competitors, we preheat the crankshaft using induction. The preheating temperature can also be kept constant during the laser cladding. The big advantage of preheating to about 250 degrees and maintaining the temperature is that the risk of increased stress in the heat affected zone can be reduced by approx 20%. The laser cladding itself carry out with Stellite 21 with more than 37 HRT for all steel and plain bearing surfaces. The Elite 21 is a corrosion-resistant cobalt chrome alloy. And we also use Inconel 625 with more than 20 HRC for other parts such as fit surfaces for roller bearings, coupling and cone. Inconel 625 is a stainless steel with a chromium, nickel and low carbon content. The finishing after the laser cladding process was done, machined or by hand. The process steps are grinding using a grinding disc. You can see it here. Here's the disc, here's the crankshaft. Polishing by hand. Here we're polishing radial by hand, and also we are polishing radius and oil holes also by hand. Here shown on the photo. And the last step was the measurement of all repaired surfaces. Our last step before packing the crankshaft was our final inspection. We always perform the final inspection to be sure that all dimensions within the tolerance and the surfaces are in a perfect condition. Also, the bluefit check crankshaft to flywheel will be checked and documented. The final inspection consists of the following steps: visual inspection, concentricity and diameter inspection, roughness measurement, hardness test, die penetration test, all affected dimension after repair should be measured, and hand over detailed report customer with all carried out works. On the photos, you can see the final die penetration test. Yeah, here you can see a complete repair crankshaft with the 13 bearing surfaces, which are laser cladded with Stellite 21. All surfaces are grinded and also the lubrication oil holes are cleaned, and the oil radius was polished by hand. Finally, we would like to discuss when a crankshaft can no longer be repaired. In general, we have divided the crankshaft into 4 areas, with zone A being the most critical and zone D being the least critical, shown here in the sketch. When can a crankshaft no longer be repaired according to BC guidelines? When we have cracks in the radius zone A, or when the damage is more than 2% of the nominal diameter. In our case, the crankshaft would be scrapped at a diameter of 235. As I explained before, the nominal diameter was here 240 millimeters. Yeah, and now I already reached the end of my presentation, and I'm happy to hand over to Maddie. Thank you.
Thank you very much, Matthias. Hello, everyone. The case I will be talking today is from a compressor where we had to replace the crankshaft after it was confirmed that the repair was not feasible. The compressor in question is operating in a refinery in East Europe. It is an Ingersoll Rand 5HHE non-lubricated compressor, compressing hydrogen gas from approximately 1 bar absolute to 34 bar absolute, running at a speed of 370 RPM with a shaft power of 1.3 megawatt. It is a 5-crank 4-stage compressor with a stroke of 305 RPM. The situation at site was as following. The first stage connecting rod bolt got loosened, causing connecting rod to release from its position. This further caused damages not only on the connecting rod, but also led to consequential damages on the crosshead guide, crankshaft, and the complete crankcase. When the issue was reported, an immediate site visit was carried out by Burckhardt Compression experts to assess the situation. Parts were assessed to see if they could be repaired. When the damage was found out to be unrepairable, like you see in the pictures, Burckhardt Compression offered new parts. The scope of supply included a complete new crankshaft and the counterweights, main bearings, big end bearings, small end bearings, the bolts, nuts, washers, plugs, and all the locking pins as per the existing crankshaft. Once the order was placed, the crankshaft and the bearings were sent to Burckhardt Compression Service Center in Winterthur for measurement. Measurement was carried out using the latest tools like 3D scanner and of course the manually as well by our engineering experts. Material selection and design of parts and final drawings were prepared, after which the manufacturing of the parts were carried out according to Burckhardt Compression standards. Once the parts were ready, they were installed at site on the compressor with the supervision by our field service representative. Following pictures show the parts at our service center and their measurement using 3D scanner. Of course, the main thing was also the weights. The weights were also measured. In this case, we were also able to measure the parts like crossheads and connecting rods, because some of the parts were also sent to the service center, and also our engineer were on site to measure. So this way we could cross-check the crankshaft measurements and make sure all the important diameters, the crank diameters, angles, and everything were right. Engineering involved design and preparation of final drawings after the measurement was done. As you can see the 3D model of the crankshaft in the following pictures, it was also important to make sure the bearing clearances were maintained right according to OEM specifications, and we could do this through the manuals we received. Once the parts were manufactured, final inspection and measurements were carried out. All the parts were carried out, all the parts were manufactured according to Burckhardt compression standards and quality inspection and test plan. And then you can see the final shipment. The parts were delivered within the expected timeline, and the installation was carried out with the supervision by our field service crew. To summarize on both cases, the repair as well as the re-engineering, in both cases, we provided quick response to the situation. Immediate site visit for inspection and quick offering was done. Best and comprehensive solution was generated after detailed analysis on the complete situation. In general, we are able to provide different cost and time-effective repair and reverse engineering options. When a repair of a compressor or its components is not feasible, we can provide alternative solution like revamp or reverse engineering. Parts were installed with supervision by Burckhardt Compression field service crew in order to ensure that they were installed right. As demonstrated in the beginning of the webinar, we significantly contribute to sustainability by reusing components and entire compressor systems. Thank you very much, and I hand it back to Daniela.
Thank you very much, Matthias, and also Madhurya, for your insights. To help us get better, to make valuable sessions for you, we really would much appreciate your feedback on today's session. You can see here the link. It's just a short survey that you will have to fill out. So that would be very great. More information about our capabilities you, of course, also find on our website. And if you are interested to get further invitations to our webinars, please register. So we will add you to our list and you will be informed well in advance about new sessions. So we are at the end of our presentation. Many thanks to our audience for being with us today. And to our speakers, a special thanks, Matthias and Madhurya, and the team in the background who made that possible here. The recording, as I said, will be available on the Burckhardt Compression TechXchange site and shared also on social media. Feel free to reshare with your colleagues who may have not had the time to join the live session. So have a great day, and until next time, goodbye.
Thank you very much.
Bye. Thank you.